coordinate and using the double integral, I will just quickly review of polar coordinates, and then we will see how we can use the double integral in polar coordinates. Well, as a review for the polar coordinate, remember we have a point here which is given by xy, the Cartesian xy, which is how many steps we go to the right, we call it x, how many steps we go up, we call it y. There is another description for that using two numbers. The first one, you describe it as the theta, the angle between the x-axis and your point, and how many steps you need to move diagonally like this to reach that point. So if you know this number here and you know the theta, of course you can change into xy and yx. Now, the equations that will be used is the same equation that we know. If we use Pythagorean theorem, we get x squared plus y squared equal to r squared. So if you know x, if you know y, definitely you will know r by using this equation. Again, if you know y, you know x, you can use the tan inverse to get the theta. So we can find the polar coordinate if we have xy by substituting in those two equations. So this is kind of a way to find the polar coordinate for a point given x and y. Next, we can do also the opposites. What do I mean by the opposite? The opposite means if you have r, just use cosine theta with it, you will get x. And y will be r sine theta. So again, either I give you r theta, you can find x and y, or we can do the opposite. So it's kind of a relation that goes both ways. Give me xy, I give you r theta, give me r theta, I give you xy, and those are the relations between them. Now, why do we need to use polar coordinates? From where we got this idea of using polar coordinates? And why do we call it polar in the first place? Well, if you look at the submarines in the ocean, they navigate not by having x and y. They don't go vertically and horizontally in the ocean. All what they do is they use this one. I think you have seen it in many movies. This device, where if they want to move to this point, they need only to set up the angle and then they see how many steps in that direction. So set up the angle and move in that direction. So this is how submarine is used to move. And of course, usually submarines, they go under the water, especially in the polar. If you go to the North Pole or the South Pole, you need to go under the ice cap. And that's what we call it, polar ice cap. This is just kind of a history for your information. And this is always how the scope will work. Find the angle and then move all steps in that angle. Of course, don't forget that theta will be measured in radian and r will be measured as a positive number. For example, if we have this one here, if we look at this and we want to change from xy into r and theta, what will happen is, first you have to tell me how r will move. Of course, r will always start from the origin and it will start moving toward the end of my region. And we have to think about it in all directions, how this movement happens. Now, because we have a circle in this example, we are so lucky because if I go from 0 to this direction, I will reach 1. Again, if I go to this direction, because it's circle, again, I reach 1. If I go to this direction, again, I reach 1. This direction, again, 1. So in all directions, I'm moving from 0 here, and maximum I will reach is 1. This is just a simple example, and we are lucky because this is a circle. So this is how we find how r moves from where to where. Again, we will need this because we will do double integral and we need to know r from which number to which number. However, for theta, we have to start from the beginning of the region and we go all the way to the end of the region. And we see how much angle did I do by moving from beginning to the end. It's more like you put an arrow here and then you move this arrow to the end of the region. And that will give you 0 because the first arrow was at 0 angle. And then if you move the whole way, that means you made an angle of 2 pi, which is 360. And that's how we find theta from which number to which number. Now, why do I like to do this? Because this is a very easy double integral, number to number, number to number. We know how to do it. Double integral of a rectangle, it's the best situation. However, if you don't want to use polar coordinates, you will have a very difficult time find out if this is region 1, type 1, or it's type 2, or you need to separate it into 2 different types. It's a whole story. So polar coordinate will give you a shortcut and easy way. Now, let's move to the next example. Now, for the next example, we know that R starts from here, from this point. This is where R will start. Of course, I always imagine it starts from the origin, but this is the starting point here, and it will end up here. And that happened in all direction. In all direction, it starts at 1 because the circle has radius 1, and it stop at 2 because the circle has radius 2. It's written 4 because that's the square root of that's the square of 2. So we get it from 1 to 2. And that's in all directions. Now, the next step is to see the angle, and here is the angle. I start from the angle 0, and I go all the way until here, which I make 180, and that's what we have here for the angle. Now, how do we evaluate the double integral in polar coordinates? Well, how we do it in this way. First of all, we need to change every x in the question into r cosine and r sine. That's easy, right? Again, we need to find r is between which number and which number, and we need to find theta between which number and which number. And that's exactly what we just did in those 2 examples, here and here. After we find r and theta, all what we need to do is we need to put dr d theta. It doesn't matter if you want to start with r theta, but usually we start with r. If they are numbers, it doesn't matter, but maybe they are not numbers, but usually start with r and then theta. But then there is a tax here we need to be careful of, which is this one. This is extra. You just have to add it as an extra value when you do the integration. And that's the only difference. When you move to polar coordinates, we have to pay the price, we have to add something extra, we have to put this r, please don't forget it. Sometimes this r even helps you simplify the integral. While it looks complicated, but help you simplify the integral. And finally, please don't forget this additional factor, which is r, that is here. Next, we'll do this example.